Hello dears, in the last class we had discussed about the fundamentals of kinematics. We introduced what is vector. So what is the difference between vectors and scalars? Scalars means physical quantities that has only magnitude, no direction. Okay. What are the examples of vectors? Speed, distance, time, mass, temperature, energy, power, pressure, etc. Okay. So what about vectors? Vectors is nothing but physical quantity that has both magnitude as well as direction. Okay. What are the examples of vectors? Velocity, displacement, acceleration, force, momentum, electric field, magnetic field, weight. Okay. So also we had discussed what is the difference between distance and displacement. What is the difference between distance and displacement? Distance is nothing but total path length covered by the object. Okay. And what about the displacement? Displacement is the shortest straight line path covered by the object in a specific direction. Okay. So what about velocity and speed? What is speed? Speed is nothing but how fast an object moves. Okay. Or you can say speed is the rate of change of distance over a time. Okay. And what is the formula of speed? Speed equal to distance by time. What about velocity? Velocity is nothing but rate of change of displacement or displacement over time. Okay, so these things we had discussed in the previous class. In today's class, we are going to discuss vector in detail. Okay, so in today's class, I will deal with vector operation. What is vector operation? Operations that are performed on vector quantities. Okay. Now, first one is vector multiplication. Okay. What will happen? A vector will multiply. Vector is multiplied with scalar. Okay. When we multiply a vector with a scalar, what will happen? Direction will be same, but the magnitude is changed. Okay. For example, here vector A is multiplied with scalar 2. We will get 2A. Okay. Now, the next one. What will happen? A vector A multiplied with a scalar half. That is half A vector. Vector A multiplied with -1 gives minus A vector. Okay. Now, when a vector is multiplied by a scalar, the result is a new vector that has same or opposite direction as the original vector, but its magnitude is scaled accordingly. Okay. So, if k greater than 0, then the direction will be same, but the magnitude direction same, direction same, but if k is less than 0, here this case, if k, here what is k? K is -1. K is less than 0, then direction will be different. Okay, so multiplying a vector A with a constant scalar k gives a vector whose direction is same or different. Here you should write different. Same or different, but the magnitude is changed by a factor of k. Okay, understood? So this is vector multiplication with scalar. Next is addition of vector. There are three types of vector addition, that is triangle law of vector addition, parallelogram law of vector addition, polygon law of vector addition. Okay, now we can discuss each type in detail. First one is triangle law of vector addition. Okay, what is triangle law of vector addition? If two vectors are represented as two sides of a triangle taken in an order. Here, look at the figure. If two vectors are represented as two sides of a triangle taken in order, then the resultant is given by the closing side of the triangle taken in the opposite order. Okay, I will repeat. The triangle law of vector addition states that if two vectors are represented as two sides of a triangle taken in order, then the resultant is given by the closing side of the triangle taken in the opposite order. Now I will explain. Okay, here I take vector A and then I take vector B from the head of the A vector. Then the resultant is draw an arrow from the tail of the first vector to the head of the last vector. That gives the resultant that is formed as the sum of the vectors. Okay, so first draw the first vector, then draw the beginning tail of the second vector at the head of the first vector. Continue to draw all the vectors in this way. Draw an arrow to connect the tail of the first vector to the head of the last vector. That the vector that is formed is the sum of the vectors. Understood? Okay. This is called triangle law of vector addition. Next comes parallelogram law of vector addition. The parallelogram law of vector addition, when two vectors are represented by two adjacent sides of a parallelogram, tail to tail, like this. Okay, then diagonal gives the resultant. Okay, if this side is A and this side is B, the diagonal gives the resultant. Okay, in the parallelogram law of vector addition, when two vectors are represented by the two adjacent sides of a parallelogram, tail to tail, then diagonal of the parallelogram will represent the resultant vector starting from the common point. Okay, so how to resolve the parallelogram law of vector addition? First, draw the vector A, then draw the second vector starting at the same point as the first vector's origin, that is from here. Then complete the parallelogram. If this side is B and the opposite side, this side also will be B. Why? Because it's a parallelogram. Opposite sides of a parallelogram are equal. The diagonal gives the resultant. Okay. If the angle between the diagonal and first A vector is theta, we can find the tan theta. Okay, here how to find the resultant? You can choose this as a triangle, then apply Pythagoras theorem. If this side is A and this side is B and the angle here is theta, what will be the diagonal? Diagonal will be r equal to root of a square plus b square. Okay, so what are the steps? Draw the first vector, draw the second vector starting at the same point as the first vector's origin. Complete the parallelogram by drawing dotted lines parallel to each other. Draw the diagonal of the parallelogram. For two vectors that are at an angle 90 degree to one another, find the length of the diagonal by applying the Pythagorean theorem. And then from this triangle, what is tan theta? Tan theta is opposite by adjacent, that is b by a, that is theta equal to tan inverse b by a. Understood? Okay. So what is Pythagoras theorem? We can just recap. In a right angle triangle, the square of the hypotenuse side is equal to the sum of squares of other two sides. Okay. Now the next is vector resolution. How we can resolve vector into components. What is vector resolution? The process of splitting a vector into its component is called resolution of vector. Once more, vector resolution is the process of breaking a single vector into two or more components along chosen direction, usually along perpendicular axis. Example, horizontal and vertical. Okay, here this is the vector A that is splitted into AX and AY. Okay, so the vector resolution is the process of breaking a single vector into two or more components along chosen direction. Okay, here first we can talk about the horizontal component. Which is the horizontal component? This is horizontal component and this is vertical component. How to calculate horizontal component? Here, this is horizontal component. So here, vector A, this is vector A and this side is AX and this side is AY. Then what will be this side? This side also AY. Why? Because this is a parallelogram or rectangle. So opposite sides are equal. So what is cos theta? If this is a triangle, this is AX, this is AY, and the angle between AX and hypotenuse is theta, then what is cos theta? Cos theta is nothing but adjacent by hypotenuse, that is AX by, if hypotenuse is A, then AX by A. Then rearrange. What will be AX? AX is A cos theta. Okay. AX is A cos theta. Similarly, for the vertical component, that is AY. How to calculate AY? Here, what is sine theta from this triangle? Sine theta is opposite by hypotenuse. What is opposite AY? Hypotenuse is A. So we will get AY equal to A sine theta. Understood? Okay. So I think you are well aware of vector operation. What is vector addition? What will happen? A vector is added with a scalar. When a vector is added with a scalar, its direction can be uh, it, its direction can be same or different, but the magnitude will be changed accordingly. Okay, then we discussed about vector addition. There are three types of vector addition: vector triangle of vector addition, and parallelogram law of vector addition, polygon law. Polygon law is not included in your syllabus, so we can talk only about triangle of vector addition and parallelogram law of vector addition. In triangle of vector addition, if two sides of a triangle are represented by two vectors, then the resultant is the third side that is in the opposite order. Okay, what about parallelogram law of vector addition? If two sides are represented by the two sides of a parallelogram, then the resultant is given by the diagonal. Okay, so then we had discussed about vector resolution. Vector resolution is nothing but processes of splitting a vector into its component is called resolution of vector. Uh, Here, if the a vector is resolved, breaked into horizontal and vertical component. Horizontal component is ax, that is a cos theta, and vertical component is ay, that is a sine theta. Okay, understood? Okay, thank you for listening.